Hello guys and welcome back to another episode. Today we are going to be looking at a room from TryHackMe called Rest Conditions. It contains three binary exploitation challenges that are, I can say, they teach about rest conditions. The room is a bit hard as far as I'm concerned, given the fact that it took me close to 12 hours to solve the last challenge after solving the first two challenges in like less than an hour, but it was a good learning experience. I'm not the best person to explain C programming or even how to code in C, but I hope you're just going to go through it and, with the little knowledge, maybe I can help you, put you in the right path in terms of trying to learn exactly how these kind of vulnerabilities work. So, the first two challenges are a bit easy. As far as I'm concerned, we are going to also be doing some sort of programming. So basically, I'm going to teach you exactly how to do a bit of Bash programming and Python programming, and then from there, probably just going to be calling it a day. So let me just get the URL for the box so that we can just look at the instructions before beginning exploiting the box. So here it is. It's also going to be in the description when I'll be uploading the video, but also I recommend that if possible you can just keep on subscribing to the channel to make it grow, and make it to become probably even a community one day. So the challenge starts by saying that in the home directory of work, run and sprint, you'll find three vulnerable SUIDs binaries: the C code and the flag. Your task is to exploit the binaries to read the contents of the user's flag. The challenges are independent of each other and can be done in whatever order you want. It is, however, recommended that you start with work, because trust me, work is the easiest challenge of the three. Then it says that allow the VM about 3 to 5 minutes to begin before you can actually try to search using the credentials that are provided below: the username of rest, then the password of car. The reason as to I'm using a new browser, it's because I have the flags, but we'll see how to make things work. So the first thing that I need to do is to first of all log into the system, and I'm going to log in via SSH. Remember, they've said that SSH is open. The box has been running for close to 15 minutes, so it's going to be up already, so we don't have to wait for another 3 to 5 minutes to begin the challenge. So we've managed to log in into the system, but I'm going to be needing 3 pens, and you're going to see exactly why in a few. So let me just try to SSH to the two other pens, not boxes. So that's the first one. Then the second one, here it is. Then let me again use the password of car. So there it is. So remember, they say that start with work before you try to exploit the other binary. So let's just go look at work. And as you can see, as they said, we have three files. One is an SUID binary. Here it is. You have the source code for the SUID binary. Then you have a flag. A flag, probably it's just a flag that you're supposed to submit to get the points for that specific system. So let's start by doing a static code analysis to see exactly, the, the kind of vulnerability that the application might have. So as you can see, it just has one function. That's the main function. It takes arguments. It creates some buffers. Then as you can see, it says that if two arguments are not provided, read the following prompt, then exit. Because as you can see, it just returns here. Then after that, if you provide both the binary name, then you provide the file that you want to read. First of all, it does two checks. First of all, it checks that the file you have provided is not the flag. Remember, let me go to the next pen, then do an ls. Let me go to work. Remember, this is our flag. So first of all, what it does is it checks that whatever file you're trying to provide, first of all, number one, it's not the flag. This is the check. Then the second check, it tries to ensure that whatever file you provided is not a symlink. So if either of those conditions are not met, you'll see that it will print nice try, but I refuse to give you the flag. But if those two conditions are satisfied, it will see, first of all, is it possible for you to read the file? If possible, then it allows you to read, or else if you can't read the file, it just gives you an error. So that is where this else statement comes in. So if you look at this code, you'll see that the vulnerability are in this one line get char, because what happens is the program expects you to give it a character before it continues the execution of the program. So first of all, it does the necessary checks. Those are the security checks, then pauses. So during this pause, what we can do is we can undo all the security checks in our file, then probably get the flag of the system. To just demonstrate this, because it's the easiest challenge, let me go back to my home directory. No, not even my home directory. First of all, let's just execute flag, anti-flag. Then as you can see, it needs me to provide a file. If I try to provide a file that does not exist, let's see what happens. It says that, it can't read it. So basically it gives you this error that probably it can't read the file, which is still okay. You don't even have to worry about that. So the first thing that it's going to do is, let me just provide the file called test. Then after that, it has already done the necessary checks, at least I think. Then let me just echo I want to test and see exactly what will happen. Okay, so probably these are just leftovers from the system. Let me just rm, then do an echo again, then you can just look at it. So there it is. It gives you an error because you didn't provide the full path. So let me provide the full path. Home res test. So there it is. Then it just reads the file because you have access to the file. It's nothing interesting. But I want you to remember one thing. It said that we can't do symlink. So basically we can't just do a symlink to these flags so that we can actually read the flag. But remember, these checks are done before the program pauses its execution. So let's execute the program one last time. Then it says that it's going to read test. Remember, test is this file that we had initially created. So the next that I'm going to do is to remove the file test. Then after that, create another symlink. Now this time I'm going to symlink/home. Then I'm going to do walk, then flag, then put it as test. Remember, already checks have been done. The check for symlink and the check for uh, that the file you provided is not the flag, they've already been done before the program paused its execution. So even if we change here, the check has already been done. So basically, it's a way that we've can say that we've managed to bypass that check. So if I continue the execution of the program, you'll see that we get the flag, and the first challenge has already been solved. So let's move to the second challenge. That is going to be run. So let's just look at run and see if we can solve it really quickly. But first of all, let me just clean up the system so that we can start from a clean slate. So that looks okay. So the next thing that I'm going to do is to go to run. So cd run. So these are the files that we are supposed to read. Also, let's just go through the source code a bit. But as I said before, I'm not really good at explaining C code, so you'll just have to bear with me. So let's go to run, then do a vim cat2.c. So first of all, it does the checks like before. It just checks to ensure that you've provided 2 arguments in the script before it continues execution. Then after that, it just prints these to the screen, so nothing interesting. Then after that, it executes this check security context. So if you look down here, that's a function that returns an integer, whereby it just checks the access. So the access is supposed to check for 2 things. First of all, it checks that you have access to that file. If you have access to that file, then it can actually read it. If you don't have access, it won't read it. But remember, this program doesn't process anywhere. So these checks, it's done momentarily. The only thing that is different is that it sleeps for 500 microseconds. So this is where the vulnerability comes in, because if we automate the exploitation, you'll see that these 500 microsecond is actually a huge time for us to be able to perform that race condition. So to do this, what I'm going to be doing is to go to the second screen. Remember, right now we're supposed to be executing run, but before we execute run, I just need to show you exactly how the exploit is going to work. So for us to do that, let me just create exploit.sh. It's going to be a really simple bash script. So user bin env, not Python. I'm used to coding in Python a lot, that's why. Then the next thing that I'm going to specify is a while loop. So while true basically just tells the script that I want you to continue executing this script infinitely, so it won't actually stop the execution. So the first thing that I want to do is to touch a file called test, because that's the file that we've been using to deceive the application that it's vulnerable, or no, not vulnerable, but to deceive the application that it's a correct file that can actually be read. So after that, I want to create a symlink from this file. So to do that, I'm going to specify the command ln-s, then -f. Basically, -f tells the symlink program that if that file already exists, just override it to become a symlink. So -f then specify the full path. Now it's going to be /home/run, then specify flag, because this is the flag that you're trying to read for challenge number 2. Then after that, you're going to call it test, which is going to be the name of our symlink. Then lastly, what I'm going to be doing is to remove test, so that we can actually begin the entire process again. So after that, I'm going to specify done. So basically, our script is just going to be running infinitely till we decide to press Control-C. Then it's going to be doing these 3 basic functions. So to just check on it, what I'm going to do is to close it. There it is. Then execute it. So exploit, or let me do bash exploit.sh. So there it is. You can see that the program is already running as we speak. And before we even try to exploit the vulnerability, let me show you exactly what's happening in the background. The things that we can't actually see. So if I go to run, not run but res, because that's where we've saved the script. So there it is, res. So if I do a watch -n, then specify 0.1 to tell it that I want it to sleep for a total of 0.1 seconds, then do the following operation, which is ls-la. So if I press enter, you'll see that what is happening is, for every few seconds, it's creating 2 files. Number one, it's creating a file called test. Then momentarily what happens is it symlinks that file to flag. Then a while again, it deletes the file, then creates it all over again. So basically, this is the check that is being performed right now. So let's try and see if it's possible to exploit that vulnerability with this in mind. So let's go back to home, then specify run. Then the script you're supposed to exploit is this one, cat. Then the next thing that we need to provide is a file name. So let me provide the file name that we created in our bash script. So it's going to be home, then res, then specify test. So here it is. So let me execute it, and it says it didn't work. So we have to execute it a couple of times for it to work. Remember, the first 2 times the conditions were not met, but as you can see, the 3rd time the condition was met, and you can actually see we got the flag. So basically, this is how we are supposed to solve the second challenge. Just try to, the moment that script sleeps for a total of 500 milliseconds, we change the file, then read it even though it's a symlink. So basically, that's how the entire exploit was supposed to work. So that is how we solved the second challenge. Let's go to the last challenge, which actually was a headache to me. So let me not delete this file, because I think I can just save these scripts on my GitHub page. Then in case somebody wants to refer, I'll just post a link in the description once I post the video. So the third challenge, it says, let's look at it. What is the flag for the home sprint flag binary? So basically, this is the hardest of the 3 challenges as far as I'm concerned. And it's supposed to be some sort of a banking application, as you're going to be seeing it in a second. So to do it, let's first of all go back. So here it is. Then go to sprint, which is the last challenge that took me like the last 12 hours to just figure it out. So let's read through the source code. Then from there, we're going to be solving it first of all using ChatGPT, because my first thought was probably we're supposed to exploit some sort of a thread, but it didn't work. So I had to actually, read through the code with ChatGPT for me to understand exactly what I needed to exploit before, even starting to create an exploit. So let's go to sprint. Then let's read through the source code. Then we can just execute the system binary for us to see exactly how we're supposed to exploit. So first of all, it contains two functions. That's the main function here, it is. Then the second function is called run thread. So let's start by just looking at the main function. You can see, first of all, it just creates some sort, not even some sort, it creates a socket that is an IPv4 socket. Then after that, in case it gets an error that it can't bind to port, it gives you that message. If it cannot connect, it tells you this message. Then after that, if it can connect to the port, it prints out this specific message, whereby it tells you that this program only accepts three commands, that is deposit, withdrawal, and purchase flag. So after that, any a time, if you connect to that port, it will return this message whereby it says that connection received, creating a new thread. Then here's the thread that it creates. So basically, after creating a thread, what happens is it will be executing these three functions. These are not even this function here of run thread. So if you look at the run thread, it says that if the user specifies deposit, what the application is going to do is simple. It's just going to add 10,000, I can say, dollars to your account. Then if you do withdraw, it just withdraws $10,000. Then lastly, if you try to purchase flags, what it does is you require $15,000. If it doesn't match that, it will tell you that you don't have enough money. If you have enough money, it will read you the flag. Then after that, it will remove 15,000 from your account. So that appears to be okay. But I had a really hard time trying to read through to exploit this challenge. So what I'm going to do is to do something that I've seen most practitioners do of late, but given this is a CTF, I think it's not that bad. We're just going to read through the code with ChatGPT to tell us exactly, what looks vulnerable. So let me, first of all, just give me a second. Let me log into ChatGPT, then we can actually just, continue with the walkthrough. So I'm just going to be pausing the video for a bit, then we're going to continue. So I've managed to log into ChatGPT. Then the next thing that you're going to do is to just start a new chat. Then you can just, probably just, ask ChatGPT to tell us exactly where the race condition is in that program. So what I'm going to be typing, let me just increase my font a bit so that everyone can see exactly what I'm doing. So I'm just going to be typing where is the race condition in the following code. So sorry about that. So after that, I'm going to go back to my system, then provide it this code so that it can actually analyze and tell us exactly where the exploit is. So what happened is, as you can see, I already have the binary on my system, but let me just say, for the purpose of showing you exactly how you can do it if you don't have the binary on your system. If you don't have the binary in your system, you can just use SCP to copy the binary from the box to your system because you already have SSH. So let me just delete it, then do an SCP, then specify race at the IP address of the system, then specify where the binary is. So the binary is in, give me a second, let me get it, home sprint banking system. So home sprint banking system. So let me copy banking system, then we can just copy the file to our system. So home, sorry about that. So home, then specify sprint, then specify banking system think.c. Then you're going to save it in banking system.c. So it's going to ask us for a password, which is, remember, it's car. So let's wait and see if it's going to copy it. And if you do an ls, you can see that it managed to copy the binary to our system. So let me just copy this binary to my clipboard using the command cat, then specify that, then type xclip, then dash selection, then specify clipboard. I hope it's clipboard. If it's not, it's primary. It's always one of those two. So let's see if it's going to work. Yes, there it is. Then let me run it. Then I'll let ChatGPT to see if it can actually analyze the binary. So it says that the race condition in the following code occurs when multiple threads access and modify money variables simultaneously. The money is a shared resource, that can be accessed by multiple threads running concurrently. So basically, for us to be able to exploit this vulnerability, we need to have two concurrent threads. So it says that in the code, the money variable is modified in two places without proper synchronization. Inside the run thread function, if the buffer contains the string deposit, which is the money variable is incremented by $1,000. If the buffer contains the string withdraw, the money variable is decremented by 1,000. So if the buffer contains the string purchase flag and the money variable is greater or equal to 15,000, the money variable is decremented by 15. At the end, the run thread of the run thread, you see that the money is reset to 0 by setting the money equals to 0. So let's just go back and let me show you exactly how this happens. Then we can start creating an exploit for this specific function. As you can see, this is where the transaction happens. Let me call it a transaction because you're either getting your money, depositing money, withdrawing, or even purchasing something. Then what happens is it's supposed to sleep for 1 second. So basically, the moment you deposit money, what happens is it sleeps for 1 second. Then after that, it decrements the money again to 0. Then after that, it's like what it does next. It closes the socket. So it closes the socket. Then after that is that it just exits through the thread. So what you're going to do is uh, create an exploit for this specific vulnerability, because it's something that you can't actually do by hand. Remember, you have 1 second to ensure that you have at least 15,000, let me say, dollars for you to be able to purchase the flag. So I'm just going to be doing my programming or coding using Visual Studio, because it's actually the best IDE for Python, as far as, that's my own opinion, but as far as I think, it's something that I've actually liked coding when it comes to Python. So let me first of all just increase the font a bit to ensure that everyone is able to see exactly what I'm doing. Then from there, what you can do is to walk through the exploit. Let me close the welcome page, then type Python. So basically, this is where we're going to be creating that Python exploit. It's going to be, let me say, a medium difficulty exploit to create, but I believe it's a good learning opportunity. So first of all, what I need to do is to provide user, then specify bin, and then specify Python 3 to tell it that this script is going to be a Python 3 exploit. So basically, it should execute it in the context of a Python 3 exploit. Then from there, I'm going to be using from pawn import star. Basically, this is one of the main binaries that you're supposed to use when you're trying to do any sort of binary exploitation with Python. And if I type Python 3 in my command prompt right now, you will see that if I import that module, it exists. So let me just import pawn so that you can see that it actually exists before even we begin. From pawn import star, you can see, just let's give it a second, you can see that pawn to the library itself actually exists. Then from there, I need to import sys so that we can actually exit from a thread if something happens. Then after that, what I need to import is threading. So let me import threading because we need to background one of the functions. So import threading. Then lastly, from concurrent dot futures. Remember, we're supposed to execute something concurrently. That's where this module actually comes in. So from concurrent dot futures, import. No, let me not do that because I have to import a couple of things from concurrent. So let me do import concurrent dot futures. So there it is. So those are the four main modules that we need. Then from there, let me just specify the main. So if underscore name underscore equals underscore main underscore. Then from there, this is where we're supposed to specify what the script is actually supposed to be doing, which is not that hard. So the next thing that I'm going to do is to create two functions. So one of the function is going to be doing depositing funds simultaneously. So basically, remember, we have that time period of 1 second. So we need to ensure that we we deposit at least $20,000 for in that account, and we need a function that runs concurrently trying to do that deposit. So to do that, what I'm going to do is to create a function called fund. So def, then create fund, then specify -I, which is just going to be there as a placeholder. You're going to see exactly why. Then after that, I'm going to create a variable called connect, then specify fund, which just, this is just a variable, so you can actually name it anything, which is just going to be saying that you're supposed to connect to a remote process. It's going to be hosted in 127.0.0.1, and you're asking myself, why exactly am I getting this 127.0.0.1? So if we go back and if I type exit, let me see if it's going to work. So there it is, but my internet seems to be really slow. So let me specify banking system. You can see it has created a connection on port 1337. So if I come to my lower pane, then the next thing that I do is type NC 127.0.0.1 port 1337. You can see that I've managed to connect to that socket. Then doing deposit, you'll notice that it says that the current balance is 1000. Deposit, if I do a deposit a second time, still it says it 1000, because the moment that thread dies, that money is also decremented again to 0. So basically it needs to be as fast as I told you. So we're just going to be connected to this socket using pawn tools, then do that simultaneously. So to do that, what we need to provide is, let me see. You need to provide that IP address, then provide the port that it's supposed to connect to, then that is already okay. So after that, what we need to do is to send that deposit command, tell it that I want you to deposit this amount of money. So to do that, I'm just going to be using connect fund dot send, then I'm going to be sending a line. Then after that, it's supposed to be in a byte format, as you can see from the help menu. So here it is. Then just say deposit. So there it is. Then after that, what I need to do is to get the balance. So the balance is equals to be connect fund dot receive. So let me just type receive all. So there it is. Then what we need to do is really simple. I just need to print this to a screen. So let me do print balance. So there it is. So basically our function is just supposed to be that, whereby it just connects to that socket, then in that moment it just does funding of a wallet. So the next thing, I'm just going to be doing def, then creating another function called purchase, and this is supposed to just purchase our flag. Then it's going to be doing the same thing again, using a different thread, connect to port 1337, that is port lit. Then after that, just try to purchase the flag simultaneously. So to do that, I'm just going to be specify a second variable, connect to purchase equals, then specify the remote. There it is. Then specify, sorry about that, specify 127.0.0.1, still port 1337. Then the next thing that is going to do is to do connect purchase dot send line, to actually send a line which is supposed to be a byte, which is purchase flag. Remember, this is what you're supposed to do to purchase a flag, to just send this command. And remember, if you don't have enough cash, what happens is, if you try to purchase a flag, it will tell you that, sorry, you don't have enough money to purchase that flag. So let's just do it. Then after that, what it's going to do is to say flag equals, then let me say connect purchase dot receive all, then just print it. So I'm just going to print flag. Then lastly, I'm going to do if. Let me just do an if statement and you'll get exactly why I'm actually doing an if statement. Then, I'm going to explain another concept to you in the next few, because this script is it's just going to execute purchase function at once. So if flag, let me say if THM, because we understand that that's the format of the flag. In flag, what I need you to do is to simply print. Let me do log.success. Then I need to specify a message that it's just going to be success flag. Sorry about that. Then let me do flag from whatever it has received. So let me do an f string here to tell you that this is what I need to do. So remember, what is happening is I'm trying to create an exploit that what it's supposed to do. It's really simple to execute this purchase function infinitely. So for this to happen, what I need to do, let me create a variable called I and let I is equals to 0. Then after that, what I'm going to do is say if while I is less than, let me say 1000, then run these functions. So let me just get these functions, then put it in the required place. There it is. So that looks okay. Else, let me just do pass for the time being. If in case we get any errors, we can just come back and look at the challenge. So the next thing that I need to do is to specify both of these challenges in my main function so that they can actually run. But remember right now what is happening. If I try to specify purchase, it will work. But if I come down here then try to specify fund, what will happen is, given the fact it will have to wait for these 1000 executions to happen before the function fund is called. So what I want to do is to run both of these functions simultaneously, and that is where the library called threading comes in. So let's just run this function in a thread to tell it that while these other functions are being executed, execute these in a different context. Basically just fork it and execute it in a different thread. So to do that, I'm just going to be specifying the purchase thread, purchase underscore thread equals threading.thread. So here it is. Then specify the target, which the target basically just specify the function that I want to thread, which is the purchase thread. Then lastly, to tell it purchase thread dot start. So basically it's just going to start the thread. Then after that, what I also need to do, remember, we need to execute this fund function simultaneously while this purchase thread is happening, to tell it that what I want you to do is, while this purchase thread is running, try to continue depositing cash as much as I want you to do that. So to do that, I'm going to be using this module called concurrent dot futures. But remember, what I also want to do is that if it gets THM in the flag, to do assist.exit. Basically just exit from this while loop. So that appears okay. So let's start creating that concurrent thread. So we're going to be using the command with concurrent.futures.thread pull executor. So there it is. Then specify max workers. So let me specify a max workers of 10 threads. If it doesn't work, we'll just increase it later on. So as workers, then after that, let me say work is equals to, then specify workers.submit. So this is where we're supposed to be submitting our task, and to submit our task, the task that we want to submit is just this funding of a wallet. So let me specify fund, then specify. I remember it's supposed to be just this thread, but don't worry about it. You'll come to understand exactly why I'm specifying that. So it's going to be colon, then I, for I in range, let me put it 0 to about 1000. So there it is. Then after that, remember, the fact that purchase is executing 1,000 times, I also want fund to execute 1,000 times. That's why I've specified the range to be 1,000. Then lastly, what I'm going to be doing is for features in, then specify concurrent dot futures dot as completed. Then it's going to be work, don't do anything, then do just a pass. There it is. So basically, this is probably how our script is supposed to look like. I hope it works, but we've done writing our script. So basically, these are 1,000 threads. It's going to be running every instant. It's going to be running 10 threads, but you can increase it in case we'll need it. But right now, what I need to do is another one thing. But I feel like we're already doing it. It's just printing balance. Remember, we need to see the balance to see if actually our exploit is working. So to do this, what I'm going to be doing is to copy this exploit, go back to my Windows box, then create an exploit.py, vim exploit.py, then do a set paste, then just paste the entire thing inside, then do python 3, then specify exploit.py. You can see it's executing the script almost instantaneously. So basically it's working, but given the fact that it runs really fast, you can't actually see if it worked. So let me just type balance to save the output to a file called balance. There it is. So basically, we get an error, but still it managed to complete the process. So the next thing that I'm going to do is to just cut balance, whereby you're supposed to get the entire output. Then after that, the one thing that I'm interested in is to see this balance, not receiving, because this is just Spawn tools just telling me that things are working as expected. So I'm just going to be grabbing -I to grab for balance. So here it is. You can see there it is. Then after that, the last thing that I'm going to do is to grab -V 10,000, because remember, for a single thread, it was supposed to only deposit 10,000. So if I find some money that is greater than 10,000, it means that our exploit worked. And as I look at the screen, I'm seeing already something interesting, because as you can see, we even managed to be able to deposit 30,000 at a time, because we are running the threads concurrently. So it means that probably one of our purchase function might have worked, because at that time the thread had close to either 20 or 30,000 dollars. So to see if any of our any of our if any of our functions, the purchase flag function worked, what I'm going to do is to just cut balance again, and this time, instead of trying to grab the balance that was in our account, I'm just to be grabbing -I thm. So there it is. And as you can see, it seems like I don't have the flag. Might it be because of the function that I got? Let me wait and see. So let's just go up, because I thought it could have worked given the fact that it gave me that error. But anyway, let me just execute it again. Let me just execute the exploit again and see if we can manage to get that error. Yes, it says type byte object is required and not string. So basically it says that we need to convert THM to a byte instead of a string. So to do that, what I'm going to be doing is really simple. Just add a bit to tell it that whatever you need to get is a byte. So let's copy the new exploit. Probably this is why you're not getting the flag. So let me just rm exploit.py. Then after that, let me do another vim exploit.py, then do set paste to just paste the source code that we had initially written and hope it works. So let me paste it again, then do a rem balance, then run it again. So there it is. So we no longer get that error that we had got initially, whereby it wasn't able to convert a string to a byte. So right now, let's just try to see if we got any 20,000 or 30,000 in our account during that thread execution. So as you can see, we managed to get about 20,000 and even 30,000. And even as you can see down here below, we actually got the flag a couple times. And just to make it clear, let me just do a cut, then specify balance, then grep -I thm. So, and there it is. So we ran the threads like 1,000 times, but only 2 times did it work, as you can see here. So we managed to solve the challenge. We can submit the flag and get the points for the box. So basically, this is how you're supposed to solve all the 3 challenges, and I hope you enjoyed the walkthrough. If so, please just subscribe to the channel to help it grow. Then I'll see you in the next video. Goodbye.